Hello, good morning to one and all. So, as we know that in previous classes we were spoken about, we were study about single plate clutch, multi plate clutch, cone clutch, and centrifugal clutch. These are the four important classification of the clutch. So, four different kinds of clutches in automobile engineering, in automobile sector. So with that, by studying of four kind of clutches, we have finished the clutch concept. Then, whereas coming to that next concept, which is under the syllabus, the concept is called as a fluid flywheel. So the fluid flywheel is also one kind of clutch here, but it is a hydraulic clutch, or sometimes it is also called as a fluid clutch, right? So clutches are made by mechanical concept. These fluid flywheel clutches, it is a one kind of clutch. These kind of clutches are constructed by using fluid as a media, but their mechanical components are using to operate the clutches. But here the operating clutches are by using of fluids. So the kind of fluid is either air or sometimes using as a oil, right? So the kind of oil is fluid oil. Fluid oil, using of the fluid oil, the clutches are operating here. So as we know that the importance of clutches, so the function of the clutches, that and all we studied in the previous classes, right? So that is the one thing here. Come to that, a fluid coupling or hydraulic coupling is a hydrodynamic device. It is a hydrodynamic device or hydrodynamic component which is used to transmit the rotating mechanical power. Transmit of what? Transmitting by what? Rotating of mechanical power. Power can be transmitted, the kind of mechanical power, but the power is transmitting, power is passing through the mechanical component, which is called as a coupling. Which is called as a coupling. So I'll tell you that how coupling is constructed, how mechanical power is constructed there. It is also known as a fluid clutch. So fluid coupling, which are couples the drive member with the driven member through the medium of fluid. So as we know that the mechanical power is transmitting by two components. One is the driver member and driven member. So the mechanical power is transmitting through driver member and driven member by using of a fluid as a media. By using fluid as a media, the fluid as a medium, that is called as a medium of fluid. So it has been used in automobile transmission as an alternative to the mechanical clutch. So as we know that mechanical clutches are nothing but single plate clutch, multi plate clutch, cone clutch, and centrifugal clutches. These are the mechanical clutches. So to those kind of clutches, the fluid clutch or hydraulic coupling is using. Fluid coupling or hydraulic coupling or fluid clutch is using, right? So in a fluid coupling, there is no mechanical contact between the drive shaft and driven shaft. As we know that in the mechanical concept, in mechanical clutch, there are the plates. Between the plates, there are the pads are there, friction pads are there. So the pads and clutch pedals are contacting to each other by springs through the pedal operation, so that the power is transmitting, the power is taking that engaging and disengaging. So whenever the power is engaging, then power being transmitted. Whenever the power and the plates are not engaged, then disengaged, then the power not being transmitted. So that we know that we have studied that. But that is a mechanical power transmission. But whereas here, so there are no physical contact between the driving member and driven member, even though there is no physical contact between those two components. But the physical contact, the contact is done by through the fluid media, through the fluid. So fluid is striking driving member and driven member continuously with high speed, with high pressure, so that the power being transmitted, the kind of mechanical power being transmitted through the rotational shaft. That is what we are going to study here, right? till now, up to now, you just be keep in mind that there is no contacting between the driving member and driven member, but even though the power being transmitted, it transmit power from one shaft to another shaft with help of the fluid or oils. So fluid or oil is placed between the driving member and driven member, then power being transmitted, that we know. Then come to here. It also has a wide spread of application in marine and industrial applications, because it is the main application of the fluid coupling or hydraulic brakes are marine and industrial applications. When various speeds operations and controlled startup without shock loads, the power transmission system is essential. So in order to take the various speed of operations at initially at the starting of the vehicle, then without jerks, the kind of couplings are using, the kind of fluid coupling is using. It consists of two members in which one driving member and another one is driven member. Already informed you, already I explained how these are. Among them, the driving member is connected with the flywheel, engine flywheel. That means that the driving member is connected to the engine flywheel. Means that there is a what? There is a flywheel. Flywheel is directly connected to the engine. So on the flywheel, to the flywheel, the driving member is connected. Of driving member is connected. That means that fluid driving member is connected, and the driven member is connected to the driven member, right? The driven member is connected to the driven member is connected with the transmission shaft. Driven member is directly connected to the transmission shaft. Driving member connected to the engine, and a driven member is directly connected to the transmission shaft. Next, come to this is the construction of this turbine. This is the way of construction of this fluid flywheel, right? Fluid flywheel or fluid coupling, not to fluid flywheel, fluid coupling or hydraulic coupling. So hydraulic coupling consists of a pump impeller. So as I said that there are the two important components, one is driving member and another one is driven member. On driving member the pump is connected, on driven member the turbine is connected. You can see here, this is the input shaft which is coming from engine through flywheel, so which is connected there. This is called as a pump and this one is called as a turbine. So turbine and pump both are connected in a single house, but there is a small gap in order to flow the fluid, in order to contact the fluid to the impellers and blades, right? Impellers are constructed with pump, blades are constructed with turbine. So turbine is on output shaft, that means that on transmission shaft. Impeller or pump is on engine shaft. That is what we studied up to now. So later on we'll see how the working principle is here. Can see here. The hydraulic coupling consists of a pump, impeller and runner turbine runner, which are identical in shape, but those are in a different shape, because impeller is a one kind of shape and turbine is a one kind of shape. That is why those are in identical in shape, completely housed in a oil filled casing. So this is the house. So in the house the oil filled is there, oil is filled, then between them only, between the between these two the oil is flowing, between turbine and pump the oil is moving, so that lateral function is taking place. Typically mineral oil is used as a working fluid. So we can use any type of oil, but according to automobile, the mineral oil is the best oil in the in where in hydraulic coupling. The pump impeller is connected to the driving shaft. That only, the pump impeller directly connected to the driving shaft, and the turbine is secondary wheel, is directly connected to the driven shaft. So primary wheel and secondary wheel is also called as a turbine, pump and turbine. So right, pump is also called as a primary wheel. Turbine is also called as a secondary wheel. Next, you can see here how this has been working here. So here the pump wheel is directly the pump is connected to the input shaft on the input shaft, which is directly connected to the turbine engine shaft through flywheel, and the turbine wheel is directly connected to the transmission shaft. So already I said that there is a fluid inside of the housing. Mineral oil or fluid. Mineral oil is a fluid. Oil is a one kind of fluid which is poured inside, which is already filled inside of the housing. So whenever the power is coming from engine through this shaft, so that the shaft will get rotates. So once the shaft gets rotating, that the pump is also gets rotates. So whenever the pumps is gets rotates through the turbine impellers, pump impellers, the oil, the fluid is the fluid is getting energized. The fluid is getting energized. So the kind of fluid energized is striking to the turbine blades, its turbine blades by passing through the along by passing along the impellers, right? By passing the kind of fluid is by passing through along the impellers, and then later on it is striking to the turbine blades, so that the kind of energy is utilizing by the turbine blades, and turbine gets started to running, so that continuously the power being energized through the impellers and striking to the turbine blades, so that the turbine blade is get started at some rpm, at certain rpm. So after some time the turbine gets also transmitted, the turbine gets also rotated continuously with the same speed of input shaft. So the I can say that simply the input shaft is equal to output shaft after striking the fluids to the turbine blades. Then and there the power being transmitted to the output shaft. That means that the transmission shaft. That is what the working principle here. So the fluid is passing along the impellers and it is striking to the turbine blades. Then again it is come back to the impellers. Then again it is going to the turbine blades. So continuously it is taking a number of spiral cycles, circular cycles in the housing, and try to get the making into that constant speed of the input and output. Then and there the power being transmitted. That is what the working principle here. So you can see this beside diagram also. So this is the construction of 2D diagram, this is the 3D diagram. So there the turbine runner is there, casing is there, input shaft and output shaft both are coincidence. Then whenever the input power is coming from the engine, then by consuming of input power, the impeller, pump impeller are rotating. The once the pump impellers are rotating, the fluid which is filled inside of the housing is try to pass along along the impellers and striking to the turbine blades. So after some time the constant speed must be taken place input and as output. Then and there the power being transmitted. That is what the working principle is taking here. Next to come to this. So both shafts are coaxial here. As I said that both shafts are in the previous slide also I shown you that both shafts are coaxial. Then and the torque runner have vanes to guide the fluid flow in the direction. These two are mounted in the same direction, same coaxial direction, and provided a small gap between the turbine and pump. So, right, the kind of gap is allowed to flow the fluid flow the fluid between the two sections, and gets energized pressure, and through that the turbine blades are rotating. So right, the wheels are facing to each other with very narrow clearance between them. The narrow through that narrow only the fluid flow is take place, because the narrow space is provided to increase the pressure of fluid. So for that only narrow space is providing, and they also guided the fluid flow in the desired directions, right, in the desired directions. Next, come to this. So coming to that working principle. I'll take you through that working principle of fluid coupling, how it is taking place. So before start into this, just to have a one example, how fluid flow is taking place here, fluid coupling is working here. So I taking the two fans which are kept opposite to each other. This is the one fan and this is the another fan, two table fans. So one table fan is connected to the power in, so another table fan is not connected to the power in. So by using of a one table fan which is powered in, which is switched on, so through that I would like to run the other fan. So let's see how this working here. So as we know that when the two fans are kept opposite to each other, one fan is running, another fan is not running. So by consuming of a air, by consuming of a fluid or concept of this which is plugged in, through that the power the other fan is running. See here, when once the switch on this power, this switch on this fan, so automatically the fans, the wings gets rotations, so that the keep on wings are rotating that, so there is a some amount of air which is produced by this fan. So the kind of air is passing to the passing through and reach to the opposite fan which is placed opposite of that, and then and there the kind of spiral air is striking to the opposite fan. So the kind of spiral air is work on the fans which is placed against of that, and then the fan wings are also rotating opposite, the fan wings also rotating. That is what we know, that working principle means that by utilizing of working fan air, then opposite fan wings also rotating, opposite fan wings also rotating. That is what we see in here. This is general application. So same situation is working here, the same situation is also working here, but it is in open place, but it is not in open place, it is placed in a closed vessel, closed housing, because the fluid is somewhat costly and the fluid is not go out from that. So if keep on the fluid is coming out from the blades and impellers, then the fluid cannot be filled again and again. So that is why it has been placed in a closed housing, right? So when the engine is started, as we know that when the fan is gets started, the air is the spiral air, the wings air is striking to the other fan. So that is what here, when the engine is started, the driving member is called as a impeller. So always pump is rotating here, pump wheels are rotating, because it is directly connected to the input shaft. So to start move inside of the housing containing oil, right? So once the shaft is rotating, shaft is moving, the fluid is start to move through the impellers, and it will reach to the oil is reached to the turbine blades with high pressure, right? The turbine, the impeller, the fluid is striking to the turbine blades with high pressure. So pockets of moving driving member are completely filled with oil. Due to this centrifugal force is centrifugal force, the force of oil is outward radials, right? So once the oil is moving along the impellers with centrifugal force, because there is a movement is taking place by input shaft. So through that the centrifugal force would be developed along the centrifugal force on the impellers. The oil is gets forward direction, outward forward direction. Then finally what will happen, the pockets are designed in such a way that the splashed oil will be strike to the pockets or veins of the driven member. That means that turbine blades, it will strike to the turbine blades, hence it is forced to the move on the same direction, right? Hence it is move forced to move in the same direction. Then and there the power cannot be lost here. So when the engine speed is increases, the oil which is coming out from the pockets is driving to the socket of this driven member, right? When the engine speed is increases, the oil also gets the oil also gets energized through the centrifugal force, and it is passing and it is moving along the impellers and striking to the turbine blades, so that it tends to move rotates in the same speed, right? because whenever the speed is increasing, the centrifugal force is imposing on the turbine impellers and it is striking to the turbine blades. Then it is going back, then it is coming back, then it is going back. Like that, the working principle would be taken place, so that the same speed of input and output would be take place on this. Then that is what the working principle of here. Then coming into that advantages, so there are few advantages are there. Give smoother power take up than the centrifugal type of the engine is accelerated, right? So no need of separate pedal and lever to be operate. There is no wear on moving parts because friction cannot be produces there between the input and output shafts, but fluid is filled between the input and output shaft, so that the kind of friction is avoiding to moving of the parts. No need to adjustment of required. So when you take single plate clutch or multi plate clutch, the gears are required to change of this, but here need not require any gears. No, directly we can change the adjustment of need of adjustment. So it is a constant measurement, constant torque is moving, so no maintenance is necessary. Maintenance is not required, so because smoothly it is running, simple in design and no skill required is operate. Then there is no jerks on transmission when gear engaging. So no jerks on there because it is a fluid coupling, so hydraulic coupling. So that is why no jerks cannot be produced at maximum case. So come to that, there is some disadvantages. Let go through that through disadvantages. Go through the disadvantages. There is a drag on the gearbox shaft even at slip is 100% because there is a fluid coupling is there. So through that fluid, through that fluid, the slippages can be taken place. So that is what one disadvantages here. Then gear changing is difficult in order to crash type of gearbox, right? In ordinary crash type of gearbox, but some most of the cases we are not going for ordinary crash type of gearbox, but it is simple type of gearboxes. So that is why it is more advantageous than that. But when using of this only, the drawback is come out by using of epicyclic gearboxes to avoid this difficulty, because epicyclic gear train is there in automatic transmission system. So I'll take you through the epicyclic gear train in coming days. There is also torque converter is there. This is the fluid coupling. Then next concept, it is a torque converter, automatic transmission system. So there we can see that epicyclic gear train. So by placing of epicyclic gear train, we can avoid this ordinary crashing type, all those things. So that is what that disadvantages. Next to come to that, some applications are there. Already I take you through the applications, industrial applications and industry and race vehicles and rail transmission systems and automotive systems and aviation systems. So these are the few advantage applications of this fluid coupling. So the finally my conclusion is fluid drive coupling cannot achieve 100% of efficiency, but it has much appropriate efficiency of 98. But even we using of this mechanical clutches also we cannot get 100%. But compared to mechanical clutches, the kind of fluid coupling or fluid clutches is more efficient because it is providing 98 percentage. But whereas compared to mechanical clutches, it cannot give 98 percentage. We can go for 70 to 75 or maximum cases 80 percentage, because 20% losses are there due to friction. But here the 2% losses is coming from the slippages, right? Most of the cases the slippage is taking place here. So that is what about fluid coupling. So simply I can take you that fluid coupling is a one kind of clutch. It is also called as hydraulic clutch, hydraulic coupling, or hydraulic clutch, or hydraulic fluid coupling. It is consist of two components. One is driving shaft, another driven shaft. Between the driving shaft and driven shaft, the fluid is filled. It is completely placed in one house. then it is connected between the engine and the transmission system. So whenever the engine is running, the engine is running, the engine gets started, the impeller, the pump is gets started with respect to engine speed. Then the fluid is gets centrifugal force inside of the impeller. It will pass through the impeller and it will strike to the turbine blades. So once the fluid is striking to the turbine blades with centrifugal force, then by taking off a outward direction of the forces, then turbine also gets started to rotating because it is mounted on the shaft with bearing. So that is why with less amount of striking force also it will strike. Then finally it will come to that equal spaces. So that is what the working principle of this. That is what the working principle of this. The working principle of this, right? So next class I'll take you to the other concept. So I hope that you have understand of what is fluid coupling, what is the working principle of fluid coupling, advantages of fluid coupling, disadvantages of fluid coupling, and applications of the fluid coupling. Okay, guys. So next class I'll take you through that other concept. Okay. Have a nice day. Thank you one and all to join with me.